Respected faculty members, very good to see you all. Today I am here to provide you important methodology and guidelines regarding DPT 6 physics. In DPT 6 physics, you are entitled to give practice in electricity 2. In electricity 2. So in electricity 2, we consider the most important electric circuits. Electric circuits is the main topic. In that, first you practice of quick check summary. Quick check summary should be provided thorough practice. After that, concept build-up. You have to familiarize the concept build-up. It is very, very important. So electric circuit, here we are concentrating on utilizing electricity. Already we spoke at length the source of electric energy. The source of electric energy is electric cell. The electric cell, it will utilize the reactivity series and produce charge and make everything available. The electric cell contains cathode and anode, which are energized, which are charged by is already charged due to the difference in chemical reactivities of various elements taken in that electric cell. They get enough charge, so chemical energy is completely converted into electric energy. It is ready. So from electric cell, what will we do? We take this connection, these charged electrodes, which contain charge produced Q with the expense of chemical energy W. So what is the potential prevailing over there? V is equal to W by Q. With the expense of chemical energy, every unit charge is produced with the expense of how much chemical energy? W by Q. So what you call it as potential difference is produced across the terminals of the electric cell. Now what will we do? By means of key, tap key, that ammeter, after that we take a utilizer. It may be utilizer like bulb, consumer. We take consumer, electric iron, electric bulb, different types of consumers are taken, and upon connecting them by means of voltmeter, connect voltmeter across it, immediately across this the consumer, potential difference is produced. Now discharge will be taking place. Here charging will take place inside the electric cell utilizing the chemical reactivities. So charging is completed. Now we are carrying out here utilizing the electric energy or discharge, what you call it as discharge is taking place. Discharge or utilization of electric energy. Utilization of electric energy. Here what we are doing, you have to familiarize children. What we are doing, how it is happening, these dialectics are to be made familiar. So, utilization of electric energy, already cell is made charge. With the expense of chemical energy, charge is produced. What is the formula? V is equal to W by Q. While discharging, what is the formula? W is equal to VQ. V is the potential difference applied across the consumer, any bulb or electric iron or any gadget, mixie, grinder, anything. Whatever you come across, we apply potential difference V. Closed circuit is paved, and by means of voltmeter and ammeter it is connected. Then charge will start traveling. When charge is traveling, we rate I is equal to Q by T. Rate of flow of charge will be rated by ammeter will give the measure of what is the rate of flow of charge. So the charge Q is transferring across the terminals having potential difference V. What happens? Energy will be dissipated. flowing charge releases energy. That is the main motive of total electricity. Flowing charge releases energy. That is the main theme on which the total electrical engineering is depending on. So therefore W is equal to VQ and W is equal to Q means you can write IT. So the electric energy produced, electric energy can be given by the expression W is equal to VIT. When you connect a gadget, applying V volts, flowing current I for T seconds, then what is the energy drawn or released, utilized, that will be given by W is equal to VIT. So after that it can be expressed in joules. Electric energy is expressed in joules, or it can be taken in the other form, watt hours. Electric energy is also taken in the form of watt hours or kilowatt hours. Watt hours, joules, watt hours or kilowatt hours. Kilowatt hour is the unit of electric energy. 1 kWh is given by 1000 watt hours, which is equal to 1000 into joule by, watt means joule per second, into hour means 3600 seconds. It will be equal to 36 into 10 to the power of 1, 2, 3, 4, 5 joules. That joules, 36 into 10 to the power of 5 joules will be called as 1 kilowatt hour, which is the unit of electric energy. It is the unit of electric energy used for domestic purpose. Domestic purpose. Electric energy used for domestic purpose, that is to be carefully familiarized. So in this mechanism of utilizing electricity, we have to connect 2 or more consumers. How they can be connected? First of all, the main motive is, if you want to utilize the electric energy, you have to provide potential difference across it. And then current will flow, and the flowing charge releases energy. That particular gadget, utilizing that energy, it will function. Some bulb, if it is bulb, it will produce light. If it is electric iron, it will produce heat. Likewise, we get the utilization of electric energy. So every student should be familiarized to utilize electric energy. What are needed? Potential difference is to be applied across it. Then current will flow. How much energy you have drawn? W is equal to VIT. What is the power of the gadget? Power is to be familiarized. Power means, rate of work done. P is equal to W by T, or W is equal to P into T, you can take. Power. Then you can take the formula W is equal to VIT here, or you can take by applying Ohm's law, V is equal to IR. You can also incorporate here. It will take the form I square RT. If you take V is equal to IR. Afterwards, if you take I is equal to V by R, it will become V square by R into T. So by introducing all these things in this power equation, what do we get? Power can be expressed as VI or I square R or V square by R. So these are the expressions for power dissipated. These are the expressions for electric energy consumed. These are to be carefully familiarized. Now let us talk about the combination of different combination possible in this aspect. While utilizing the electric energy, we can have 2 types of combinations. What are those? Those combinations are series combination and parallel combination. Series, parallel. What do you mean by series combination? When 2 or more gadgets are connected end to end, when 2 or more gadgets or resistors connected end to end, by incorporating ammeter is incorporated in between them. If they are connected to an electric cell like this end to end, such that same current will pass through them. What is series combination? Means they should be connected end to end, and number 2, same current should pass through them, then such combination resulted is called as, what do you call it? Series combination. Series combination. So in series combination, what is there? First thing, you can show anywhere you keep the ammeter, any place you can keep the ammeter, you can see same current will be recorded. Same current reading will be obtained. So what is the first feature? I is same. Same current is flowing through all gadgets. Second important thing, by keeping voltmeters, the potential difference V applied will be divided V1 across this V2, here across this V3. And total combination is, the total combination is provided with what you call potential V. So we observe total potential difference applied is V across each resistor across R1. What is the potential difference? V1. Across R2 we get potential difference V2. Across R3 potential difference must be V3. The potential difference will be shared or divided, but current will remain as same. Here we get V1 must be in accordance with Ohm's law. IR1, V2 must be equal to IR2, and V3 must be equal to IR3. But we observe the total potential difference V is equal to, third important feature, V1 plus V2 plus V3. Substituting all those things, let the combination, let this total combination is offering the resistance R, resultant, R total, R resultant. So RT is equal to, what happens? I into RT is equal to IR1 plus IR2 plus IR3. So cancelling all these things, we get the fourth result. Total resistance will be equal to, resultant resistance is equal to sum of their individual resistances. This is what you call it as important features of series combination. Please give practice to all the students, especially workload examples and in-text question problems. In text, three problems are there and workload examples are there. So please give practice of all those examples and make student thorough. In recent FA2 also, you can see the mathematical numericals are given by the government paper setter. So therefore, you must make every student alert in practicing numericals especially. We may get numericals also. It was made clear in FA2 paper, numericals are present in human. Same manner in electricity also, you can get this in numericals. So give this practice. Once a series circuit is given, students should be able to find out what is the current flowing, potential difference across given resistor, total resistance, what is the power consumed. These all must be familiarized. So here interesting factor is, here R1, R2, R3, different resistors. The most important thing, the power consumed. The power consumed P is equal to P1 plus P2 plus P3. The power consumed P is equal to, how much it will become? P1 plus P2 plus P3. How much total power? I square RT is equal to I square R1 plus I square R2 plus I square R3. The total power will be shared. Whatever the power they have drawn, energy they have drawn per second from the battery will be shared by all three resistors simultaneously. Now coming to the very important question, in series combination, who will consume more power? Greater resistance will consume more power. Obviously, you can see these values. Greater resistance consume more power. Suppose if I say 10 ohms and 50 ohms, 10 ohms and 50 ohms are connected in series, which will consume more power? 50 will consume more power in series, because all are provided with same current. Higher resistance obviously consume more power. Now coming to other important combination, that is